Hello and welcome to the first video, hopefully part of many more videos to come, covering topics of the Cisco DevNet Associate exam. So this session will cover the topic of software development lifecycle. So what we will go through on this session is software development lifecycle, or SDLC, and then we will look at the SDLC models, and then we will finish off by looking at the common design patterns. Whether you're building a house or a network, you need a good approach and clearly defined steps. And software development is not any different. Here you also need a set of standards and rules to ensure you end up with a solid and clean code. These rules will be in stages, starting with planning. This is where you identify what your software is meant to solve. So in this stage, you also run through the requirements analysis. And then you move on to defining stage. This is where you define what will the software achieve. The next stage is designing. So this is where you take your specifications and translate them into design concrete specifications. So an important thing about this stage is you need to sync your views with the stakeholders and ensure you are in agreement and your design is in line with the expectations of the business. And once this is sorted out, then you can move on to the building stage. So this is where essentially you will sit down and start coding and creating your software. So now that you have gone through all these phases and tested your software, you're ready to deploy. You can put your software into production, and typically you will kick off with a pilot, which means that is a limited scope. It's not a full-blown deployment. The next thing we will look at is the popular or the most common SDLC, software development lifecycle models. So there are many, but for the purpose of the DevNet Associate exam, we will only focus on Waterfall and Agile. So let's start with Waterfall. When you look at Waterfall, the steps or the stages in Waterfall, they are very similar to what we have already looked at. You have your analysis or your planning phase, your design, your code, your test, and your maintenance. But all these phases have a dependency, meaning that you cannot code until you have designed and done your analysis. You cannot test until you have a code, and you cannot do the maintenance until you've tested and you've known about bugs and issues with your software. And basically one phase falls into the other. So this looks very good and looks very efficient and is in line with what we have already looked at in the previous slides. So some of the issues with this life cycle is that when you take a look at the timeline, you could actually end up spending a lot of time doing your analysis and design and coding and so forth. But really, you have not achieved much. You have got nothing to show for. You got 50% completion, or you are 50% through your process or your project, and your code is 100% unusable. You don't have anything to show for it. And also, if the stakeholders have changed something fundamental in the business case or in the requirements, you actually have to go all the way back to the analysis stage and start redesigning and coding. So it's an awful lot of time, and this model is not that efficient. And the answer to that is actually the agile lifecycle. So when you look at it at face value, it looks exactly the same as what we have looked at before. So it's not that much different from the previous process. You got your analysis, you got your design, you got your coding and testing phase and so forth. The difference here is that the whole process is broken down in sprints. So it's broken down in smaller segment or smaller projects. So in this example, I have taken 5 different deliverables, if you like, and this makes it more manageable. So as a team of developers working on this software deployment or this project, it will be a lot easier and a lot more efficient to break down this life cycle in smaller sprints. And again, if you go back to the timeline, you can see that at 40% completion of the project, you got 100% usable code. So you got something to show for. You're also very flexible and agile if there are any changes pushed by either something that you found down the line or the stakeholders again have changed their mind. So you can go back and make a quick adjustment, which is a lot more efficient than the waterfall lifecycle. So on this last session or this last slide, we will look at the common design patterns. Why are we using design or common design patterns is basically so we don't reinvent the wheel. So when designing software, you likely run into problems already experienced by other developers. And instead of reinventing the wheel, we make use of already created patterns or use patterns which we know will speed up your process and provide a tested solution. So for the purpose, there are more than two, but for the purpose of the DevNet exam, we will look at only two patterns, and that's the Model View Controller, MVC, and the Observer pattern. The purpose of the Model View Controller pattern is to leverage the separation of concerns and decouple or separate the application dependencies such as data access and presentation. So MVC has three parts. You got the model part, the view part, and the controller. Model and view interact with the controller, but never directly with each other. The model part conducts data operations such as updating or deleting and retrieving. The view is what the end user accesses and sees. So the view will interact with the controller either with input or received output. And the controller is simply the man in the middle. As you can see in the drawing, the view is the user action, and then he gets an update from the controller. The controller sends an update to the model and get a notification back from the model, and then pass on the update to the view. So the model and the view, they never interact. The next pattern is the observer pattern. So the observer pattern is the opposite of a polling pattern and instead consists of notifying the subscribers. So it is very efficient. Instead of polling, you actually get notifications. The observer pattern has two components. You have the subject, which is the one being observed, and the observers. The subject has a registration process which allows elements of an application, for example, to subscribe and receive notification as and when events happen. The observer is the component which registers with the subject and subscribes. So updates are then pushed from the subject to the observer, meaning that the observer does not have to do any sort of polling here. So when things changes, it could be that you have an application that shows different type of graphs from pie to bars. So if anything changes, the observer will be notified. This is the end of this video. I hope you got something out of it and enjoyed it. Please let me know if you have any comments or questions, and I will ensure I will respond. And the next video I'll be working on would be Linux Bash. Thank you for watching.